Welcome, everybody. This is a tough act to follow, but, well, I'll try to make the best of it. My name is Sylvia Dieckmann, and I'm one of the organizers of the GDG Cape Town chapter. I'm also a developer. I'm on and off a tech manager, depending on the job. At the moment, I work as a freelance developer, and I spend a lot of time playing around with different app technologies. My current focus is on Flutter and Firebase, but that changes over the years. Last week, PJ started with two things people don't usually know about him. I think that's a really, really great tradition. So I want to pick up on that. One thing you might not know about me is that I have lived and worked in 6 countries on 4 continents. The second fact, you have to wait until slide 4, I think. Might be 5. All right. Let me see how I can... All right, this works. So, why Firebase Security? I'm probably the first to admit that security can be a pretty boring topic for developers, at least it is sometimes for me. But this is not kind of the usual Alice and Bob. It's not about denial of service attacks. I mean, not that that's not interesting, but it's just not my cup of tea. What I'll be talking about today is cloud storage and how to secure your data in the cloud. And in fact, Renaud already talked about some of the aspects in his talk, so I'll be going deeper into that. Firebase makes it very, very easy for developers to start a new project. It basically provides the entire backend for you. Yeah, really out of the box. I'm a huge fan. I've been using Firebase for all my personal projects for at least the last 4 years, and I couldn't live without. But it does have some limitations. Generally, every time you use a stock cloud product to store your data, it means that you most likely access it via CRUD operations. So CRUD stands for create, retrieve, update, delete. And so you're accessing your data via kind of stock operations. And that means, as a result, that you push some of your business logic into the client. Some people consider that a bit of a disadvantage of using a general purpose backend over a bespoke backend. And it might be, but I mean, there are ups and downs. The issue when you look at it is that in any client-server architecture, the server can generally not trust what's coming from the client. You might argue that your app, let's say, enables the approve button only if the user is an admin. Fair enough. But you can introduce a bug, or somebody can hack your app, somebody can reverse engineer the HTTP request that's going to the server, whatever. So the result is the server cannot trust what's coming from the client. The solution for that is to add an additional layer of security on the server side. Basically, the approach is let the client send what they want, let the server decide based on information the server processes whether to accept a request or reject it. And that's exactly the type of security that we're talking about here now. Okay, I'm not sure you recognized the 3 icons on the last slide. They were Cloud Firestore, RealtimeDB, and Firebase Storage. These names always trip me up. As you just heard, there are about 18 different products in the Firebase suite. I thought it was 20, but 18 is fine. These 3, to me, really stick out in the sense that they all deal with serving client data on the basically serving client data in the cloud. This means that they all kind of have to deal with the same issue because they're general purpose products. Access is typically through some SDK, through CRUD operations. It's typically asynchronous, and they all, through their architectural choices, force you to keep some business logic in their client. And so they have a need for this particular type of security on the server side. And so out of time reasons today, unfortunately, I can only talk about Firestore. But the other 2 projects have a very, very similar approach. So if you get familiar with one type of security, you can very easily apply it to the other two products. RealtimeDB syntax is a bit different, but the concepts are the same. Okay, so now we'll set up a little demo Firebase project with Auth and Firestore. But before we do that, we have to take one little detour into Christmas trees. My brother runs a farm in Germany, and aside from the usual crops, he grows Christmas trees. It's common in the northern European countries to have a real fir tree for Christmas, and picking the perfect tree is a really hotly debated topic in most families. So in December, my family opens a little pop-up shop on the farm, and we sell fir trees. So that's the second fact about me that you probably didn't know. Why am I telling you this? Good question. Well, like many developers, I have a few toy projects that I whip out whenever I need to explore a new tech stack. And one of them is a little game that I put together kind of as a nod to my family. Been using it for years. I have made an AngularJS version, then later an Angular 5 version. And in this lockdown winter, I set myself the challenge to become a Flutter expert. So I did a Flutter version. And in fact, that one I liked so much that I'm trying to productize it now. The idea is really simple. It's kind of a hot or not for Christmas trees. So as a player, you get presented with a series of images side by side, kind of two trees, and you just flick away the one you don't like. And towards the end, you get presented with your tree. Congratulations, we found your perfect tree. And it's very tongue-in-cheek. The text is usually a bit tongue-in-cheek, jokey. It's meant to be fun, nothing else. What gets interesting for this particular talk is that I've put in capability, I want players to engage and contribute their own content. So they can upload content and copy, but the content has to be approved by an admin before it enters the game. So with this in mind, when I set out to write this app or rewrite this app, I came across a few business rules that I was not prepared to compromise on. By the way, I wrote it, so I'm using a large number of Firebase tools, but the most important ones are Firebase Auth, Firebase Store, Firebase Storage, and Crashlytics, and whatever, a whole bunch. But yeah, let's look at the business rules. So the most important one is I want to encourage content uploads, but I also want to safeguard the players. So content has to be approved by an admin, me, before it enters into the game. Right? The second one, players can play without authentication, but if you want to upload content, you have to authenticate. That has legal reasons. And so I get access to the author's personal information, mostly emails, not a lot, but still European data protection laws are kind of tough, and I don't want to run afoul of anything. And then the last one is I just don't want to get into a situation where somebody by accident or intentionally wipes my game. It would be pity. Although actually that's the least problematic thing. There are backups and stuff. So with these three kind of touchy-feely business rules, I then went and translated those into Firebase security rules, which, as we explained before, can be enforced on the server. So I came up with 6 different rules. Number 1, anybody can view an approved record. Number 2, any authenticated user can create a record, but only if the author ID matches the authentication and the approved field is set to false. Number 3, authors can view their own unapproved records. Number 4, authors can delete their records at any time under any circumstances. Number 5, authors can update their records even if the record has been approved, but the status must be reset to unapproved. So this is so that you can't upload harmless content, we approve it, and then you exchange it with some root comment. And number 6, admins can do anything the authors can do, plus approve. Basically, admins are gods. All right, now I want to do a quick tour of the Firebase project that I set up. Let's see if the switchover works. All right, perfect. So there's very little in here. I just said, I mentioned I enabled authentication, and I just preloaded 2 users, an admin user and a regular user. Don't try to send them email. Firebase automatically assigns a user ID that they choose, not me. That's why it's not very good to remember, but we have to live with that. And yeah, these 2, that's all I know about these users. Then I have Firestore, where I set up 2 collections. All right, here they are. 2 collections. The first one is profiles. That basically creates a record for every user that signs on. The key is the Firebase user ID. The fields, for my own sanity, I repeated the email and the UID, but it's redundant really. But what's important is this admin flag here. So for this particular admin user, the admin flag is set to true. For the regular Joe user, the admin flag is missing. The second collection is about the trees, and I preloaded that with 3 different trees. A tree usually has an image URL. So there I'd later have a safe URL into Firestore Storage. For now, I just faked something. Some copy, author UID, and just for my own sanity, the email again, so that I don't remember the UUID. And then an approved field. So in this case, for tree A, which was generated by the admin, approved is true. Tree B was inserted by the regular user and has not been approved yet. And tree number 3, C, has been again uploaded by a regular user, but has been approved. So here in Firestore, we can also now look at the rules. That's the second tab up here. All right. And this is kind of the very plain vanilla rule set that you get when you create your new Firebase project and you choose production style rules. And it's very restrictive. It basically blocks everything. The structure is you have a service, Firestore. Inside you have a few matching paths. In this case, it matches everything in your database. And then you have a bunch of methods and conditions. So methods can be read and write, and the condition has to evaluate to false. So this here isn't terribly useful yet, but we can use it to explore the simulator. That's the best ever. It's such a great tool to track down any problem you might have. So in your simulator, you can simulate all kinds of different requests. I'll stick with get here. And I'll try to do a get request of one of the objects in my tree. I don't need to worry about authentication for this particular case, so let's run it. And sure enough, my request would have been rejected. And it's not a surprise, because as I said, this is very restrictive. All access is denied. So let me fix that and change it to true. And rerun the same query, and now it is allowed. So what you don't, because it's such a simple tool and it's such a simple query, you don't see much. But if you do more complicated stuff, let's say, create requests with an authenticated user, you get all kinds of detailed information that show you why a request failed. And it really helps to debug. So if you haven't looked at this yet, please do. All right, I think that's it. So let me switch back to my slide. Yes. Cool. So this part is lifted from the official documentation. I just want to reinforce, make sure that you're really comfortable with the structure. In the top part, wait, here's my mouse. In the top part, you have kind of, again, the general syntax, service path, and then the allow methods. Now, one thing you should note here is in the allow methods, read and write are just convenient shortcuts that the read stands for get and list, and the write stands for create, update, and delete. So typically, you start out with just read and write, and typically you break it down. You often have like different rules for create versus update, for example. What you also get with any incoming request is a few convenience variables. These are just the 3 most important ones, but there are about 10 or so more. So what you get is the auth token if the user was authenticated. And then you get a request resource and a resource. And these two are interesting. So one is the payload that comes in with the request, and the other one is the data that's currently on the server for this request. So this allows you to write conditions like this. Allow update. So I'm not sure how to get rid of this bottom box here. I'll have to live with it. Allow update if, let me hold my mouse still. Okay, much better. Allow update if request resource data has a name field and the name equals resource data name. So the first part of this condition is the incoming data, that basically the payload of the upload. And the second part is the data that's already on the server. In other words, if you update this particular record, you cannot update the name, or else the request will be rejected. So this is quite powerful. All right, remember that I talked about these 6 different rules. We're going through them one by one now and are trying to implement them, and I hope to convince you that it's actually not rocket science. The first rule was anybody can view a record if it's been approved. So I start out with a plain vanilla rules file. I just refine the path a little bit. Rather than matching all documents, I want to match my tree collection. And I want to allow reads if the resource data approved field equals true. So this is the data on the server must have a field approved, and the approved field must equal true. I think I'm a little tight on time, so I'm not going to do the demo. But all of these rules later, if you want to play around with it, it's very easy to copy and paste it into the console of a Firebase project and then play with it with the simulator. All right, let's look at rule number 2. Any user that has been authenticated can create a record, but the author ID must match the auth token, the auth ID, and the approved field must equal to false. All right, this is the most complicated rule of them all, so hang in there with me for this one. The rest will be a piece of cake after this. So what we have here is a function here. I could have put this straight into the create request, but since we are going to use is authenticated more often, I figured it's a good idea to start building up a function here. So my function is authenticated equals to true if the request has an auth field that is not null. But that alone is not enough, because Firebase auth has this concept of anonymous sign-ins. So we also need to check that the auth field that's not null actually has a UID. If both conditions are true, then we know that the user is authenticated. So this allows us, as you might notice here, I broke up the write into create, update, and delete. And for the create field, I say now it's allowed if the user is authenticated, the incoming data, request resource data, author ID, matches the auth UID that's given from Firebase auth of the incoming request. So the user is not creating a record for somebody else. That's basically what this means. And finally, the incoming data has an approved field, and that equals to false. And that's it. That's basically confirmed. So any request that will not fulfill this will be rejected, and with that, our rule 2 is established. Rule 3, authors can view their unapproved records. For that, we need to know what an author is. So here, I didn't think about it. I called it as owner, but same thing, basically the person who created the record. So a person is an owner, or request comes from an owner if it is authenticated, and we already know how to check for that. And in addition, the UID that comes from Firebase auth must match the author ID of the record. And here I'm actually looking at the server-side data, not at the incoming data. If this holds true, we know that the record in question is owned by the user who's sending the request. And so all we have to do is now add this information to the read request. So this now reads, so allow read if resource data approved equals true. So the record has already been approved, or it's coming from the owner. Right? Number 4, authors can delete their records. Now, this is the easiest of them all. We already know how to recognize an authenticated user and an author. And all we have to do is add this is author predicate to the delete method. And that's it. And so this is quite obvious now. Basically, there's no other check. If it's yours, you can delete it, whatever. If it's part of the game at the moment, doesn't matter. You own it, you can delete it. Number 5, authors can update their records at any stage, but if they do, the status must be reset to unapproved should the record already been approved. Again, this is not too difficult. We'll look at the update message here, method. We know how to check for an author, so we do that again. For an owner, sorry. And then we require that the incoming data has an approved field, and that's set to false. So with this one, I have to admit, this is not the best solution. In the real world, this should have been probably done with a function, because basically an update might be, and we're basically forcing the client to send the approved field on every update. All you want to do is change the copy, and your request will be rejected unless there's also a new approved field, which seems a bit overkill. But hey, when I did these slides, I didn't know what Renault was covering. So this is one solution that works. It's just not the prettiest. All right, now we are at the last rule. This is the God rule. Admins can do anything. For that, we need to recognize an admin. And this is getting interesting again. An admin has basically 2 properties. First, the request has to be authenticated. We know how that is done. And then we take the auth ID that we get through the request, and we use it to fetch a profile record. So this is basically, while handling one request, doing another request into the same storage, into a different collection of the same storage, and comparing notes on these 2. So here I'm looking at the profiles record, at this particular record for this user. I check if that record has an admin field. I should have checked if admin is not null, and then if it equals true. And now that we have this admin function, we can just sprinkle it into read, update, and delete. We don't need it for create, but it wouldn't hurt if it were there either. So this is quite powerful now. What you see here is basically the decision is based entirely on server-side information without really taking in anything from the client. Yes, and with that, we've basically solved our problem. The app is ready for production, would be more or less. In the next steps, I just realized I forgot to set my timer, but I think I'm getting towards the end. So I won't really have time to get into this, but in a production environment, you probably wouldn't develop this, or you would develop the rule maybe in the console, but you wouldn't just keep working with it, just pasting code in the console and testing it with the simulator. What we would most likely do is keep a local file. It's typically called Firestore rules. Check it into your repo as everything else, and then deploy it with a Firebase CLI. If you do that, it has 2 advantages. First, you can write tests. So you can write unit tests. You can also use the emulator to unit test against, which is quite powerful. And then you can make it part of a normal CI/CD pipeline. So basically, you change your code, you change your security rules, it gets pushed out by itself. One little side note, it doesn't really belong here, but I think it's somewhat important. If you use Firebase Security, and you should, don't cut corners in your client code. When you access your Firebase data, like let's say you work on your repo and you fetch data from Firestore, don't be lazy about catching exceptions. This is what's going to happen inevitably. It happens to me all the time. It's like I make a little change in my database scheme. Like I decide that admin is a stupid name for a predicate. It should be called isAdmin. So I just change it. And then I wonder why my list is suddenly empty. If you keep an eye on the logs and you catch your exceptions properly and at least and surface information, you see very quickly that your security rule still looks for a flag called admin, and it needs to be updated. And yeah, this is a common source of puzzlement for me. Or yeah, by catching exception properly, you can avoid a lot of pain for you. So conclusions, this was a whirlwind tour through Firebase Security, but I hope I convinced you it's not rocket science. It's if you structure your securities file well and you work on it kind of in lockstep with your code, it is actually quite easy to maintain. Recently they had the Firebase Summit, and the keynote I forgot the name of the woman, but one of the product managers was asked what a typical mistake was that people did with, I'm not sure if it was Firebase or Firestore specifically, but the first thing they said is exactly this. Like they don't think about security from the beginning. They think about it kind of close to launch time, and then it becomes a little more painful. Also, the other thing is, I just gave you a super quick tour of the simulator now, but the thing is so awesome. If you looked at security rules 2-3 years ago, you might have gone away with the idea that it's a royal pain, and it was, I think. But it has improved greatly. It's fun to work. You get instant feedback. It's easy to debug. So there's really no reason anymore why you would keep your database open and unsecured. One thing you need to pay a little bit of attention is the cost. If you have a very busy app with a lot of traffic, simply because some of these rules, depending on what they check, might actually be considered another read request. So they can get counted towards your quota, and if you're getting close to exceeding your quota, this might be an issue for you. And yeah, I think the last one I mentioned already. All right, happy to take some questions now. If you want to read up on any of this, do start with the official documentation. It's absolutely awesome, and pretty much every problem I ever have, I find an example in the documentation. And if you want to play with my app, I'd also appreciate that. I get very little feedback, so please let me know how you get on. I'd be thrilled to hear. And that's it. Questions, anybody?
Hi, Sylvia. Great talk. Can we take some questions? From this, do I have to use Firebase Authentication to secure a Firebase storage bucket, or can I use external authentication methods?
That's a good question. I would say the two complement each other. I mean, what do you mean by external authentication methods? So you'll probably have some checks in your client code, but as I mentioned before, a server in general shouldn't really trust what's coming from the client. So I think you really need both. I'm not completely sure what you mean by external authentication methods. So if you want to follow up and give me an example, I'd be happy to give you a more detailed answer.
From Tavin, in terms of hacking into the app or mobile app, how can we strongly safeguard unauthorized entries into the app? That is Firebase. When we already have Firebase auth.
So I assume when you mean hacking in the presence of Firebase auth, what you're talking about is kind of creating new accounts. I'm just speculating again. So generally, I would consider Firebase auth fairly secure. I'm not a hacker, I have to admit. I have no criminal energy, so I do consider Firebase auth secure. So if I as a developer get presented with a Firebase token, I trust that. I think if there's a problem, it's typically more in the design of your app that, for example, you allow multiple sign-ins with the same email address with different providers. Or you allow unauthenticated auth, so people can create multiple accounts. And I wouldn't exactly call that hacking. I think it's more a flaw in your app if you allow that and you don't want it. I think adding security on the server side will not help you in this case. If your app design allows for people to create multiple Firebase auth accounts, security on the server side is not able to stop that.
Any advice for Flutter beginner developer?
The usual one, go for the official documentation. I'm actually really impressed with Google's effort to write documentation in the last couple of years. I think I find it quite useful. They are also, so start with their code labs. That usually gets you started. And then I found I came from an Android. So basically it depends. I think the Flutter journey is different depending on your background. I came from an Android background. So I found it hardest to think of this kind of whole widget design, nested widgets for everything was very foreign to me. It's like, I want to have my text moved over. I'll just add a margin here. And Flutter approaches in a different way. If you come, for example, from a React background, you have very different issues. You'll have no problems with the nested widgets. You'll struggle with something else. But there are quite a few very detailed blogs out there that specifically kind of target developers with a certain background. Like, if you're familiar with this and now go into Flutter, these are the things you need to watch out for. So I would recommend you start Googling for that.
Thank you. It's been a great presentation from Casey. From Carlos, I have a local auth method on my app because it works offline 90% of the time. And I wonder if I can secure my storage somehow. I think that's a follow-up.
Yes. Oh, I see. That's a good one. Firestore allows offline, so the SDK supports offline access. The security is done on the server, so that will, by definition, only hit when the request comes when you are online again. And actually, I've never thought about this. I should have really, in retrospect. If you, let's say, send off a create request while you're offline, that request later gets processed on the server and gets rejected. I know it gets rejected. So your security works. It just works very delayed, and the feedback for the user might not be the best. And yeah, it's a good, interesting problem to have. I haven't really thought about it, but I think so. I'm pretty confident that your security works kind of at the moment when you're online. So yeah, all is good. I see Ruben is asking a interesting, are the Christmas trees carbon neutral? Well, that's a fun one. I think so. At least they're not transported very far. So the transport footprint is very good.
Yeah, it's a great presentation, Sylvia. Do we still have any questions? Okay, I think that concludes.
I see one here popping up. You touched on reverse engineering. Any securities we should put in place against this, or any advice to avoid this? I don't really think you can do much. Basically, that's what I tried to say earlier. Is in a client-server architecture, the server needs to be distrustful. I mean, you try to obfuscate your code on the client, and that's all great. But a motivated hacker could potentially break any, kind of get through your barriers on the client. So that's why you want to have extra checks in place on the server side. Pleasure.
Okay, I think that concludes the Q&A.